It's tempting to select a variable frequency drive based on horsepower alone. After all, if you select a drive that has the same or more horsepower than the motor you're using, you should be good to go, right? Well, not necessarily. There are 6 other things you need to consider when specifying a drive. To make sure the drive can handle the motor's current demands, just read the motor's full load current requirement right off the nameplate and find a drive that's rated for at least that full load current. And that is a great starting point, but you also need to make sure the drive can handle any overload conditions you may expect during startup or during periodic or intermittent extra loading. Looks like this drive can handle 150% overload for constant torque applications and 120% overload for variable torque applications. So make sure you know what your system overload conditions are. If you expect to exceed those overload specs, then upsize the drive until you find one that can handle it. You'll also need to know if your application is for variable torque, like fans and pumps, or constant torque, like conveyors and machine control. If you're not sure, assume constant torque. Knowing the application type is important because all of the spec tables are segregated by application type. As the altitude varies, the air becomes less dense, which reduces its ability to cool. Since there isn't as much cooling available, you may need to oversize the drive to compensate for the decrease in cooling. GS4 AC drives are designed to operate at 100% capacity at altitudes up to 1,000 meters. By the time you get to 3,000 meters, the drive can only be expected to generate about 80% of its rated current. Note that this curve assumes these temperatures for the different types of standards. At 1,000 meters, GS4 drives can be operated up to 50 or 40 degrees C, but at 3,000 meters, the max air temperature can only be 40 or 30 degrees C. For example, Denver is at 1,600 meters, so GS4 drives can only be expected to output about 95% of their rated current. Which brings us to temperature. AC drives generate a lot of heat, so if the drive is in an enclosure, there is the possibility you'll exceed the max temperature ratings of the drive if the enclosure doesn't have additional cooling or ventilation. This table in the user manual tells us drives up to 30 to 40 horsepower can operate up to 40 or 50 degrees C, depending on if the ventilation cover is removed or not. Of course, removing that cover does change your IP rating. We have similar max temperatures with the larger drives. They can operate up to 40 or 50 degrees C, depending on whether they have a conduit box installed or not. They don't have ventilation covers, but that conduit box does restrict the airflow. Can you go above those limits? Sure, but you have to derate the drive like this, which is 2% for every 1 degree C above the max, with an absolute maximum operating temperature of 60 degrees C. So make sure you've measured or calculated what the temperature in your cabinet or room will be when the drive is running to be sure you don't exceed these limits, or if you do exceed the limits, that you derate the drive accordingly. A variable frequency drive takes the 3-phase sinusoidal input, rectifies it, and then chops it so the voltage sent to the motor looks like this on each phase. The VFD very accurately controls the width of these pulses. We call that pulse width modulation. So the motor feels like it's getting this, when it's really just getting a bunch of square pulses. The rate that the pulses are sent is what we call the carrier frequency. The higher the carrier frequency, the more accurately we can reproduce the effective sine wave into the motor. If we have a low carrier frequency, which only gives us a few pulses to work with per cycle, then we'll get a really crude approximation of a sine wave. So you would think we always want to have a really high carrier frequency, right? Well, no. In fact, you usually want the lowest carrier frequency you can handle. Parameter 210 is for setting the carrier frequency. And down here at the bottom, there's a great little chart. It tells us that if you want to minimize the motor noise and vibration, then you want a higher carrier frequency because you get a smoother sine wave. But most of the time, you want to minimize EMI, you want to minimize heat, you want to minimize power consumption, which means you want a lower carrier frequency. What carrier frequency should you use? Most of the time, the default is fine. But if you find that you need to reduce the noise, or reduce the power consumption, or reduce the heat dissipation, being able to modify the carrier frequency is a great option to have. So, you need to select a drive that's rated for the motor you want to use, can handle any temporary overload conditions you expect, is designed for the type of application you have, that will support your motor's needs at altitude, and can output the current your motor needs while operating in the temperature of your environment. And you can tune the carrier frequency if you need to lower the power consumption and operating temperature of the drive. Click here to learn more about GS4 variable frequency drives. Click here to learn more about Automation Direct's free award-winning support options, and here to subscribe to our video channel so you're notified when we post new videos.